Hello friends, welcome back. In this tutorial, we will study about DES algorithm. The full form of DES is Data Encryption Standard. DES is a symmetric cipher and it encrypts block of length of 64 bits with a key of size 56 bits. Now let us see the structure of DES. So you can see here, this diagram shows the structure of DES. So to understand the structure of this DES algorithm, how this DES algorithm works, now let us consider a plain text X which is of 64 bits. So first of all, what happened? The initial permutation will be performed on this plain text X, as you can see here in this diagram. And after the initial bitwise permutation, the plain text is split into two halves, L0 and R0. Both the halves are of 32 bits. Left portion is called L0 and right one is called R0. Now these 32-bit halves are input to the first round of the encryptions, and there are 16 rounds of encryption in this algorithm, and all these rounds of encryption have same structure. Now let us see what happens in these rounds of encryption. Let us consider the round I of encryption. So the input of round I of encryption will be two 32-bit halves which are the output of previous round I minus 1, that is L I minus 1 left half, R I minus 1 which is the right half. So in each round of encryption, a separate key is derived from the main 56-bit key. So the key which is used in round I is denoted as KI, you can see here. Now let us see how the output is produced in round I of encryption. See what happens, the right half of input, it becomes the left half of output, right? So right half of input becomes the left half of output. Now how the right half of output of round I is produced? See here, a function f is used, and this function takes two input. One is the right half of the input, another is round key ki. Then whatever the output is produced by this function, that output is XORed with the left half input, that is Li minus 1, right? And after that, whatever the final result is produced, that will become right half of the output, right? So what happens, there is a function f and it takes right half output of the previous round, that is right half input, and the current round key ki as input, and the output of this f function is XORed with the left half input bits, that is Li minus 1, and then whatever the result is produced, that will become the right half of the output. Now, so this is the way how the output is produced in round I of encryptions. So all the 16 rounds of encryptions produce the output in the same way. Same function f is used in all rounds. Now after round 16, what happens? The left and right halves of the output, that is L16 and R16, they are swapped to produce pre-output, as you can see here in this diagram, that whatever is the output of round 16, its left half and right half, they are swapped to produce pre-output. And finally the pre-output is passed through final permutation, which is the inverse of initial permutation, to produce 64-bit ciphertext, as you can see here, right? Now in DES, decryption is essentially the same function as encryption. Compared to encryption, only a key schedule is reversed in decryption. So it means in decryption, in round 1, subkey 16 is used, and in decryption in round 2, subkey 15 is used, and so on. So in this algorithm, decryption is the same function as encryption, and only the key schedule is reversed.